Good morning, everyone. My name is Łukasz Napora-Rutkowski, and I work in Polish Academy of Sciences, Institute of Ichthyobiology and Aquaculture in Gołysz, in Poland. I want to thank organizers of this conference and the AQUA-FAANG's leaders for inviting me and letting me present the results of our research about transcriptional differences in Cyprinus herpes virus-free response between resistant and susceptible common carp crossings. So, Cyprinus herpes virus-free is also known as COI herpes virus, and it's double-stranded virus member of Alloherpes virida. It was discovered and described in 1998. When it caused mass mortalities in Israel, in United States, and Germany of common carps. It caused mortalities of koi carp, of common carp breeding lines, but also wild populations. It is distributed all over the world, except Australia. So our world is fighting against, especially people working with carp, fight against koi herpes virus, except Australia that is thinking about importing this virus to the continent to fight using this virus against the common carp that is invasive species at this continent. In 2018, we started a family selection program that the main goal was to produce, that is the main goal to produce the line of common carp that will be resistant, highly resistant to COI herpes virus. And we used Amur common carp, that is this one, that have high resistance to this virus, but it's a slow-growing fish with full scale. In our region of Europe, we like carp without scales and also like growing fast, what is good for aquaculture. So, but the resistance of these breeding lines, except this, that in Gołysz we have, because Gołysz also work as a gene living bank, and we protect, we have 16 different lines, breeding lines of common carp, this collection from all over the world, and also from, and there are also like traditional Polish common carp lines. And for this selection program, we choose to cross a few of these lines with Amur common carp, and we produce 16 crossings family. These families were produced in single crossing, like there were single parents for each family, so one male, one female. It was not mass spawning. So we produced 16 such families. We were using our facility of recirculation systems, especially for experiments, but we also have this on earthen ponds. Like the same families are in both systems. So to check if our crossing families are really resistant, we had to make we perform a lot of challenge tests. This challenge test, we use the system of infection by cohabitation. So we were infecting few fish that are really susceptible to this virus and putting them together into tank with the fish of the family that we are testing. So after multiple trials, we tested this 16 crossing family, these first generation families. And we observed that the mean survival of these families was from 21% to 73%. So after we finish this with this first generation families, we produced 30 backcross families. These backcrossings we were doing by choosing 6 best F1 families and crossing them back to the mother family of the founder. So we were crossing this to this line that gives the establishment of this family, this F1 family. And this is how it's like a ground fish. In fact, it's a small breeder, but more or less how this fish looks like. So it looks almost like agriculture carp that producers expect. So we tested these 30 backcross families one more time to check, to establish the level of resistance. In this presentation, I use, for me, in this situation, like survival and resistance is almost the same. Like for me, resistance carp is this one that survived. Its resistance is the level of fish, amount of the fish that survived our challenge test. So we analyzed these 30 backcross families, and for challenge experiment and for RNA-seq experiment to analyze these differentially expressed genes, we choose 2 most resistant families and 2 most susceptible families. So in this, and we perform challenge experiments like we did all the time. The only reason was that this time we were sampling fish for RNA-seq analysis. This percent is survivability of this challenge test. So it was good experiment because the resistance family was 82% survived. And 66% survived. The susceptible families were very low survivability. So we were sampling during these experiments 2 times the fish. So it was just before starting the infection. It is day 0, and it was like 1 or 2 days just before the mass mortality started. Because CHV infections, it looks like that the virus developed for around 10 days, and then by 2 or 3 days, all fish die. So just before this mass mortality start, we choose the point of sampling fish for RNA-seq analysis. We sampled 8 fish at every time point for 3 organs. It was head, kidney, liver, and spleen. After the experiment finished, after we isolated the RNAs, we isolated full RNA for RNA-seq analysis and send it for RNA-seq sequencing. And after we get this data, the differential expression analysis between this resistant and susceptible families was performed, and also the 2 functional analyses were performed. It was overrepresentation analysis and gene enrichment analysis. For this gene expression and this functional analysis, we were, in fact, we analyzed 4 different comparisons. Here I will be talking about two most interesting that I think. So there will be different expression analysis between resistance carps against susceptible at the beginning of experiment, so day 0, and resistance against susceptible at 11 day of the infection. The differential expression analysis gave us thousands of genes, upregulated and downregulated, what was expected, and this what we get is the functional analysis indicated us that, in fact, head kidney and spleen tissue behave very similar at the beginning of experiment, day 0, at the 11th day of experiment. So there were very similar patterns of expression, especially connected with immunology genes. So this resistant fish, they had significant downregulations of genes connected with wound healing, blood coagulation, response to wounding. So here we see enrichment of head kidney. So here is this gene sets for this blood coagulation pathways. And here are these gene sets for spleen analysis. All of them are downregulated. And also this immunological gene, especially connected with complement activation, humoral immune response. Here is the pathways of head kidney, and here are the pathways of spleen enrichment. And these dots, in fact, they show the p-value. All of these p-value are significant. So for me, it is interesting that these resistance lines, these high resistance lines, they have downregulations of these genes that are involved in immunoanswer. After 11 days of infections, of challenge experiment, also the head, kidney, and spleen showed similar results. So, but this times it's changed that there was upregulations of antigen processings and immunoresponse genes in head, kidney, and in spleen. But still, the complement activation in spleen and in kidney was down-regulated in these resistance lines. The genes of antigen processing were significantly upregulated. In kidney, it was also observed that the cell adhesion pathways are upregulated. Liver functional analysis showed us the upregulations of metabolic processes of lipoprotein and lipid transport. So generally, like metabolic processes were upregulated, and also the expression processes like translation, tRNA transportation was upregulated at day 0, and at day 11. Still, the immunoanswer of this antigen processing and presentation was upregulated. So this is of course just like first part of this research. Now we will be looking into genes to see exactly which of them take the most part in this answer, and we try to connect them with other data. But to conclude this beginning of this research, of this analysis, in fact, I would conclude it like that, this functionalized analysis indicated that antigen processing and presentation processes on cell surface are associated with MHC protein complex might be important in establishing this higher resistance of for this virus in these resistance lines, or higher resistance lines. And also it's indicate that this complement system might function differently in resistant line than susceptible line. So I think it also might be connected with this higher resistance. What was also indicated by a group from China who works on CYP, that they also indicated that this complement system works different in this resistance lines, but they use not Amur carp, but red carp in their selection program. And also like more business aspect of this project is this, that we have the 6 families, 6 highly resistant families with resistance of more than 60% that we bred in our institute. Last year we started to use them for producing hatchlings, because we also produce hatchlings. And we use the spawners to cross them also with these breeding lines and to provide hatchlings for aquaculture. So thank you very much for attention. I would like to thank you all and AQUA-FAANG for allowing us to do this research and to give us so much courses and cooperation. That was very nice, and I hope it will last further. Thank you very much.